So we call this lab the popper lab because what we're going to do is we're going to take a racquetball and we're going to make a popper. So these boards for you to cut on, cutting boards, that you're going to use a utility knife. Make sure when you're using a utility knife you cut away from your fingers. If you don't feel comfortable using a utility knife, let me know and I can either cut it or someone else can cut it for you. You're going to want to locate, there's a seam where they glue the two halves of the racquetballs together, and you're going to want to follow that seam with your the utility knife. So you find that seam, you take the blade, and then you stab it. Okay? Now, always keep your fingers away from the blade. Don't go like this and start cutting, that's bad. Always keep your fingers away, and you just kind of use a sawing motion, kind of roll that ball around the seam. And eventually you get two halves. Okay? These are not poppers, these are halves of racquetballs at this point in time. Okay? So your popper would look something like this, and eventually it'd go wham! Okay? But they aren't ready for that yet. So right now they're just half of a racquetball. So then what you need to do is you need to take a pair of scissors, and people always judge my scissors, but I bought it with my own money, so if you don't like it, feel free to make a donation to the Tom Davies Physics Foundation Ruler Fund. No tax deductions available. I'm a for-profit organization. I don't know why I said that. I'm just kidding everyone in there. And won't buy me stuff. That'd be, yeah. I had to clarify that for the video. So you're going to need a ruler and some scissors eventually. But what happens is this wasn't going to pop because it's too big. You got to trim this thing. So what's going to happen is very carefully you are going to want to put this popper back and you want to trim small chunks at a time. And these scissors are amazing. Okay? But you kind of trim chunks like that at a time and you say, hey, that didn't do anything. You're right, it didn't do anything. Then you put it back and you slowly do that again. Now, if you are taking your time and making small chunks, and you make small cuts like that each time, and you check it, the idea is you're kind of looking for places where you see this natural circle, they kind of flare out a little bit. That's what you're going to try to trim off. You'll probably have to go around once, maybe twice, and then you'll be getting close. When they go like this, and if you wait a really long time and they pop, then if you want, you could stop there. Or maybe you want to trim just a little bit. Some people will kind of go like that, because if they're close but they won't pop and they go and then they pop, you're really close and you just got to trim a little bit more. When you trim, you want to try to make smooth cuts, because if you make some kind of jagged cuts, these scissors have a crack in their handle. Okay, see that cut right there? Yeah, you kind of got that jagged spot right there. While you could say it's not ready to pop yet, that also provides like a weak point, which then causes your racquetball to do that. And then you don't have a popper anymore. Now you have two parts of a torn racquetball that are garbage. Got half of it, that's kind of worth something. But eventually what's going to happen is you'll get to the point where they will pop. And when they're sitting on your lab table, they'll probably hit the table, which is good. Once you get to that point, you have a functioning popper and no longer half of a racquetball. You will then, to fill out that popper lab, there's some information. One of the things is mass. You take it and you put your popper on the balance that's on the table. Make sure you hit the 0 button first. And that'll measure in grams, but we need to make sure it's in kilograms. So take the mass and divide by 1,000. You're going to want to divide your grams by 1,000. Or you're going to move the decimal point 3 times left. Yeah, 3 times to the left. Okay? Then you're going to test it up on the board, and I'll talk about that in just a moment. The other thing you're going to do is once you have your popper that is functioning, you're going to take your popper and you need to measure. So this is going to act like a spring, right? It's kind of elastic in properties, storing energy, kind of spring-like. You need to go through and you need to determine how far, ultimately we're trying to figure out K. What's my spring constant for my popper? So that 1/2 K, that's what you're solving for, X squared. That X squared is how far does your popper go from the cocked position to the uncocked position. So your popper should be popping. Don't find the mass until it's a functioning popper. once it is ready to, once you have it, if you cock your popper, it will pop. So if you just kind of hold the edges, it shouldn't. Then you take a ruler. There's a whole bunch on that table. The idea is you get down at eye level and you figure out from the table to this top what is that height in centimeters. That's the cock portion. Then you do the same thing when it's uncocked, and you go like that, and then you add those two numbers together. Now that's in centimeters. Everything needs to be in meters, so remember there's centimeters, right? So 2 times decimal shift to make sure it's in the proper units. Add those, that's a 1/2 kx squared, that's going to be your x squared. Now these are 2 location problems. So because these are 2 location problems, I'm sure this is great videography right here. Because these are 2 location problems, then what you're going to want to do is you're going to want to make sure we can go and we can figure out the 2 heights. So if you take your popper, and maybe you'll need a hand with this, I've measured to the marker tray to be 0.94 meters from the floor. So you're going to take this and you're going to put it on the floor, and then it's going to go pop, and then it's going to go up like that, and then you take a marker and you make a mark. And then you do that again, and it's there and there and there and there. And then that's your 5 trials. Your heights are from here to here, 0.675 plus 0.94 for a total height of whatever that is. Average your 5 heights. 2 locations. All your mechanical energy here, ME1, is equal to your ME2, all your mechanical energy right here. Is it moving on the floor? Is there a height on the floor? Is there a compressed spring on the floor? Is it moving at max height? Is your popper still compressed at max height? And does it have a height at max height? I think that was the thing I forgot. Velocity, height, spring. And you're going to solve for K. So again, 2 things to work on today. 1, progress quiz. Answers are posted there. Also on the bottom of today's in-person agenda. And then the Popper Lab. So if you aren't here today, here's the wonderful introduction for the Popper Lab. I will make a different video that you can reference and get data from later. There you go.